Hello, everyone. Greetings from Peru. My name is Kateryne Ccama, and I'm a bachelor's in environmental engineering from National Agrarian University La Molina from Peru. And currently, I'm a research assistant at Nanoscience and Applications Research Group at Universidad de Ingeniería y Tecnología UTEC, also from Lima, Peru. First of all, I would like to thank the committee for giving me this opportunity to present this study with all of you. Today, I'm going to present the result of our project that is called Project-Based Learning as a strategy to propose solutions to pressing problems, a case of a study for designing an indoor air purification system by a multidisciplinary team of undergraduate engineering students. This study was developed along with Danae Chipoco, María Rosa Gutierrez, Luis Palomino, and Juan Rodriguez-Reyes. All of them, including, are from the following groups: Nanoscience and Applications Research Group, the Center of Research and Heritage Conservation, and some academic departments from Universidad de Ingeniería y Tecnología. All of them are from Lima, Peru. Well, let's start. In undergraduate engineering education, we usually see that courses, the subjects, have two main components, a theoretical and a practical component. And for the last one, practical activities are mostly executed under controlled environment, which do not necessarily represent real life conditions. And according to the director, he said that most of engineering students have lots of technical, theoretical knowledge, but it was observed that they lack of soft skills. So that's why we believe that there is a need to acquire real life experience, which will influence in their interpersonal and social skills. At Universidad de Ingeniería y Tecnología, UTEC, a series of courses called Interdisciplinary Project has been incorporated into undergraduate engineering curricula. And for this course, a problem-based learning methodology was applied by using real world problems in order to promote critical thinking skills, problem-solving abilities, and communication skills. And for this semester, the real problem considered to be developed was under the context of COVID-19 pandemic. A little bit about this issue is that in indoor spaces, coronavirus SARS-CoV-2 is spread mainly by two mechanisms, through airborne and droplet mechanisms. Thus, ventilation or purification systems, air purification systems are essential to improve indoor air quality, because it was found that that viruses persist in the air for long hours. So that's why there is a necessity to develop better or to improve current ventilation or purification systems. That being said, the interdisciplinary project proposed by students from different engineering fields was the design of an indoor air purification system. So now our objectives for this presentation and for this study as well are to describe the implementation of this project in the course and to share the result of surveys implemented in order to know how satisfactory the interdisciplinary project development was. Regarding the methodology, at the beginning of the semester, 3 groups were formed, and each one of them was focused on one of the following topics: user-centered design, antiviral filters, and electromechanical system design. It's important to mention that each one of them is interconnected with the other one. They didn't work independently. they share information with the other subgroups. Apart from that, the coordination sessions were held weekly, where each one of the previous groups mentioned received feedback from each other. And also to give students a better experience while they were developing this project, 2 platforms were thought to them. The first one is Notion, which is a tool that is useful for note-taking and project management. And the second one is Mendeley, which is a reference manager that allows you to make reference citations and to add bibliographies in an easy way. So these 2 platforms or applications were given to the students. About the evaluation system during this course, we consider 3 main categories: the design and development of solutions, self-evaluation, and the project. About the first one, design and development of solutions, it represents 40% of the total grade of the student. It's important to mention as well that this is an individual grade that is given by the faculty. For this category, professors consider the capacity of the student to define a problem and also to give possible solutions in terms of viability. For the second one, self-evaluations, it represents 20% of the total grade of the student. This is also an individual grade, but this is given by peers. In this category, we pretend, or professor pretends to, that the students develop an introspection process to identify their improvements and their strengths. And for the last one, the project, it represents 40% of the total grade of the course. But unlike the previous ones, this is a group grade, and this is given by the faculty. For this category, the professors evaluate or assess the proposal or the whole group developed during the semester, and this is presented at the end of the course. Well, in addition to this, in order to know how was the implementation of this course, we needed the students' feedback. That's why we carry out a survey that consists mainly in 3 sections: course expectations, soft skills, and course development. For the course expectations, we consider the students' expectations before they take the course. And also we consider the level of satisfaction after taking the course. For the second section, we consider the improvement of soft skills that students observe after taking the course, and also the professor observed after they took the course. We also consider in this part the difficulties that some students, or maybe all of the students, have to face during the development of the project. And this is because it can give us an idea of how they manage to deal with these unexpected situations. And the third section is about the course development that considers the time and some other requirements that the course asks for, but from a student's perspective. Regarding the results, for the first part, we are going to talk about the development of the work through the semester. As I said before, there were 3 groups that were focused on a specific topic. So the first group, the user-centered design group, the main result that they got after taking the course was the characteristics of the product. The second group, antiviral filters, they developed protocols for nanoparticle synthesis and their impregnations on materials such cotton or another material. And the last one, electromechanical system design. The main result that they got was the conceptual prototype, including size, shape of the purification system. It's important to mention here that for each group, in order to get these results, they needed information from the other subgroups. For example, electromechanical system design needed the information obtained for the first group, user-centered design, because according to these characteristics that other people, like normal people that usually use air purification system, with this information, they could create this prototype. And also with information obtained with the group of antiviral filters, and they developed an special filters that was part of the final system design. So all of them were complemented by each other. And about the survey analysis, with the result of the survey, it showed us a general opinion of the students towards this course, interdisciplinary project course. So in this first table, we can see the main skills the students considers that they developed during the course. So in the first table, it seems that assertive communication is considered the main skill developed by students. One of the reasons behind it is that students notice that thanks to that skill, they could have a better performance as a team. And also because most of the students come from different engineering fields, so they feel the necessity to have a better communication with each one of them in order to understand their opinions. Organization and planning capacity are the second and the third skills considered by students. They said that a team that is well organized and that also has a good plan help the team to meet the objectives of the project. And about the second table, it shows us some aspects where improvement is needed. And as we can see in this table, schedules overlapping seems to be the biggest issue for a group work. For this aspect, some students mentioned that because of the difficulty of the topic, they have to arrange other meetings or additional meetings apart from the course hours in order to exchange more information and also to keep up with the level of progress that other subgroups had. So that's why they believe that schedule overlapping is an important aspect where improvement is needed. About the second one, excessive academic load. Most of the students were in their first or second year of undergraduate students. So they consider that they spend more time doing research about the topic in order to learn about it and to be able to make a good progress during the semester. And the third one, that is about the lack of previous knowledge. Well, this is related with the previous one, but yeah, because they lack of previous knowledge about the main topic that was about the designing of an air purification system. They had to spend more time trying to learn to understand about this issue. And they consider that the course have to be a 4-credit course and not a 2-credit course, because of the time that they spent in this course during the semester was even more than a 4-credit course. Well, finally, our conclusions for this study were that after taking the course, students realized the importance of assertive communication, team planning, and collaborative work through projects. Also, students have shown positive response towards the benefits for being part of an interdisciplinary project, meeting the course expectations by designing an indoor air purification system, acquiring better use of their engineering skills to solve real-life problems. And also, it is recommended to take into consideration observations made by students in order to improve the development of the course, despite limitations such as excessive academic load and lack of previous knowledge. We would like to acknowledge that César Alonso Guillén, Sebastián André Peralta, Franco Jesús Bolaños, Oscar Alfredo Gómez, Miguel Tomás Olortegui, Yue Yang, and Yacibel Yashira Humpa for their willingness to participate in this project and for collaborating in the survey needed for this study. Thank you so much.